Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm going to talk about non-right angle triangles and how we're going to use trigonometry to solve problem involving non-right angle triangle. But before we start, first I would like just to talk a little bit about the triangles that are right angle triangles and how to find the area of those. So what we have here is few pictures. So the first one, graph diagram. So there are three graphs of right angle triangles. And how do we know they are right angle triangles? Because of this notation here, says this is 90 degrees angle. So I'm quite positive that you are aware how to find the area of right angle triangle. Pretty much is equal to half of the base and times height. So times height. And how do we, like, if you do have issues or problem remembering this, pretty much I'm quite positive that you are familiar with rectangular shapes. I'm just going to draw here on the side. So rectangular shapes, and if, for example, we have this length and this width, or for the purpose of this question, I'm going to call this B as a base, and width we're going to call height. So, and pretty much we do know that the area of rectangular shape, this one here, is length times width. It is this one here, okay, length times width, or in our case we are using different notation. So, and I'm gonna say base times height. Now what would happen if I have a line going halving this rectangle? So we're gonna have two triangles. Have you noted that I said halving this rectangle angle? So which means if I halve this, so I'm gonna only have the area of triangle has to be half of base times height, half. Or sometimes we just write half, like 1/2 times base times height. So height. So pretty much this is the area of triangle that is right angle triangle. So is this one here. However, as I mentioned before, I said today we're gonna focus on non-right angle triangle. So, and pretty much they are the one that don't have right angle triangle, or they may have, but the height is not included. Okay, we can find the area of the triangle using this formula. So some of the triangles you may have a look here. So we do have it's not right angle triangle, not right angle triangle, and not right angle triangle either, because we don't have any notation saying that they are. So how do we calculate the area of non-right angle triangles? Pretty much if we do have two sides given, one side and the other side, and if the angle between those sides is given. So same here, side 1, side 2, and angle between those sides. Side 1, side 2, and the angle between those two sides. So the angle that we need is called included angle. So angle between those two sides. And then we can find the area of the triangle. Now, sometimes we do struggle, to remember some of the formulas. So before I give you the formula, I'm just gonna go through how this formula it's constructed. So, if this is non-right angle triangle, so, and let's label this A, B, C, and respective sides will be labeled small a, small b, and small c. So And now if we do construct an altitude from A to the base, this one here, which is actually perpendicular to side A, so it's perpendicular. So we're gonna call this line here the height. Okay, so this is the height. Now what we're gonna see, okay, we don't know how to find the area of non-right angled triangle, but what we know, so that on this side here we have now right angled triangle, and we do have this angle opposite height, so let's call this angle theta. So, and using trigonometry or using trig ratio, and I may actually record a video on trigonometric ratios. So we're going to use trigonometric ratio in order to find the unknown side. And unknown side in this case for us is height. So because we do know if we have height given and base, then we can find here it's not given, it's just labeled h. So angle given, opposite is hypotenuse, and we do have B, opposite is height, and we do have B, which is hypotenuse in this case. How do we know that hypotenuse is always the opposite right angle triangle? So we have opposite given, so labeled. We have hypotenuse given, which is B, so this is H. And then we have hypotenuse given, which is B. So, and looking from this, we can see that trigonometric ratio that we should use does have sin involved, sin or sine theta. So, which is equal to opposite, it's H, over hypotenuse, which is B. Now, looking from this one here, from different color, from this trigonometric ratio, so we can find what the height is equal to. Height is equal, so what you can do is cross multiply, so it's going to be B times sin of the angle. So let's rewrite this angle here, C. So angle at point C. So just to be consistent, so sin or sine of C. So that is what is equal to, and this is just going to be equal to. So now this is the height. Now height is given. Now we do know height. And going back, area for right angle triangle is half times base. So in our case here, this one here, so we can see that base is A, and then times height, and height is there. It's just this part here, this is the height. So and instead of height, so we're gonna write B sin sine of angle C. So this is the area of formula that is used to calculate the area of non-right angle triangle. So it's easy to remember as well. So you can see if we have sides A and B here, so A and B, I'm just going to use the pointer, so A and B, and then it's sin of the angle included. However, if you have A and C given, then it's this angle there. So I have seen students using the same triangle as I used, same labeling, because they just feel like, consistent using the same notation. So however, you may change the letters and the angles, but they just have to be, if A and B are those two sides, then it has to be the angle between those two sides, included angle. So this is the formula that we're going to use. So let's go and do a few examples. So example 1, what we have here is actually two sides given. So we have two sides given, two sides given, beautiful, and plus an included angle. This is notation for angle. So this is notation for angle. So that is given. Now two sides and included angle is given. In order to find the area, it is half. We multiply those two sides, so we multiply 11 and 15, so it will be times 11 times 15, and then times sin or sine of that included angle. Okay, this one here, so it's sin of 28. So 28. Now use the calculator, calculate this, and should give you approximately 38.7, and just make sure that you do have units. I didn't label this with any units, so I can say centimeters and centimeters, so it's going to be centimeters to the power of 2. So approximately, or if you want to use equal sign, you may say equal to 38.7 centimeters to the power of 2 and correct to 1 dp. dp stands for decimal place. So I'm going to decimal place. So how many places? So 1 decimal place. If you do get an answer, and I would recommend to check this using your calculators. If you do have different answers, the possibility is when you use graphics calculators, sometimes the setting up is in radius instead of degrees. Just make sure that you're using the right setup. So that's this one, the first one. Okay, that's done. Hoping this is going well, and you understand what I'm talking about. Now the next one, again, it is similar. So it is similar. It's just angle is on the other side, but still we do have one side given and the other side given, and an included angle. So it's gonna give us half times 9 times 7 times sin or sine of that included angle, which is 42. And when you do calculate this, let me have a look. I need my calculator for this one. So it should be equal to, just give me a second. So that would be equal to 2108, and I don't have units again here, so I'm just gonna say, if you don't have units, please make sure to write units to the power of 2, and this is correct to 2 decimal places, so 2 decimal places. Okay, let's have a look. What do we have on next page? So I'm hoping that we have examples. So yes, we do. So example 3. So in triangle ABC, so now we have triangle given. Angle B is equal to 40. So A is 9 and C is equal to 10. So, and find the area of triangle ABC correct to 2 decimal places. So, the first thing, it would be actually to draw the graph here. So, I'm going to draw the graph. So, this one here, or diagram of triangle. So, and you can label how you want. So, if it's A here, B, C, we just have to be careful that angle here, this one here, angle B is 40. So that is this one here. Okay, so that's this one here. So that is 40. So 40, and A is 9, and A is opposite the angle A. So this is A. A is equal to 9 centimeters, and C is the opposite, C angle. So is this one here. C is equal to 10 centimeters. Now that we have labeled our triangle, so we can see it's easy to find the area. So again, area is equal to half, then what do we have next? Half times 9 times 10 and times sin of 40. So, and pretty much that is going to be equal to, if you want, you can simplify. 2 and 10 can be crossed out, simplify. You're going to end up with 5. Then you may say 9 times 5 is 45 times sin 40. So it depends on the person, so how you're going to do it. Let me just again calculate this. So it's 45 times sin of 40 equal to, and I do have, I'm going to go with approximately 28.93 centimeters to the power of 2. Beautiful. Now, this is all nice and easy and beautiful. 2 sides are given, and an included angle is given, but sometimes we do have problems that we don't have all sides given. We may have area given, but not all sides. So, and the question is how to find sides. Or we may have, unknown sides, and if you remember using, when we had right angle triangles, we would use Pythagoras to find those unknown sides. So what I'm going to do, I'm going to record as well when we use cosine and sine rule to find the unknown side when we have non-right angle triangle. So, but before that, let's do this example. So triangle DEF. So I have just picked, other letters, and pretty much it's just to show you that you can, label your triangle however you want. I'm gonna have here beautiful line. What color? Green. Okay, like here, little bit more. Yep, so to separate those two questions. So, but just be consistent. So, angle E is 68. So that is this one here. So that is 68 degrees. ED is 17. So ED is this one here. That's the length. This notation here, it means distance between E and D, or length. So that is 17. EF is here. EF, it's question mark, so we don't know that. So question mark, or we can label it, okay, X. We don't know that. But what else is given is actually the area. Area is given, and area of this triangle is 150 centimeters squared. So, okay, side is not given, but it's not right angle triangle. Let's have a look what we know. So we do know that the area of a non-right angle triangle is half times, 2 sides are included. So I'm going to go with A, B, and then, sin C. So I'm just going to go with this rule. So, and let's have a look what we have. A is the area. So in our case, area is given. So that's 150, isn't it? So equal to half. So 2 sides and an included angle. So we can see that we do have 2 sides. One side here. I mean, we don't know it, but that's the side that we need to find. And other side. So pretty much is times X times 17. And then again, times this, sin of included angle. So which is times sin of 68. Now the first thing here, what I would do is get rid of the fraction by multiplying everything by 2. So what's going to happen, 150 is multiplied by 2, it's going to turn into 300. And if I multiply this part here, everything by 2, that this 2 here and this one is going to cancel out. So we are left with X times 17 times sin of 68. And we have to find x. So x is unknown, and we can see that next to x we have 17 and sin 68, and we want to get rid of it. So pretty much what we want to achieve here is to get number 1. So here we need number 1 because we want 1x, not 17 times sin 68 x's. And how we can get 1 is just dividing the number in denominator here by the same in numerator by the same expression or number. So which is in this case 17 times sin 68. And you do know whatever you do on one side, you have to do on the other as well. So we are dividing the other sides by the same expression. Now this is gone because it's 1, so it's pretty much x is equal to. Now we're going to use here, I'm going to use calculator, 300. So let me have a look. 300 divided by, I'm going to have brackets, I love including brackets, times sin of 68, close the brackets, equal to. So I'm going to have approximately, I'm going to use different notation for approximation, approximately 19 of 0.3 centimeters. Please note that this here is other way of saying approximately. So we'll say approximately, approximation, approximately. And this sign here as well, this one here, it means approximation. So for this question, now we do have unknown side is given, it's calculated, and is equal to x equal to approximately 19.03 centimeters. So, and that would be all for this topic, and I'm hoping that you have enjoyed it. Thank you for watching, and see you soon. Bye.